Welcome, everyone. This is Santa Claus. I'm going to do it with another voice. Hey, ho, 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 ho. This is the end of the year. I'm so glad that you joined our live stream for December. Oh, this is perfect. No, let me use my voice. Otherwise, I won't be able to present during an hour and 20 minutes like this because it's going to be just painful for my voice. Anyway, welcome to the another Observable Lightning Talks. In fact, the Christmas edition. I mean, I'm wearing this ridiculous outfit. Maybe it's related to Christmas. I guess. I hope so. But anyway, if you're here, I'm very glad that everyone is connected. And to end this year, I thought, why don't we create another Observable Lightning Talks before starting 2025? And I was very glad that I was able to get three amazing speakers covering three amazing topics. So I'm very glad to have this session with you guys. So if you don't remember how Observable Lightning talks, let me remind how it actually works. It's very simple. The concept is a live stream event. So if you join it here, if you're connected from LinkedIn or Twitter or Twitch, then welcome on board. And this is going to be a live stream where you're able to interact with us and ask questions. But the way we are structured this event is to deliver properly all the talks that we have in scheduled today. Is we have we'll start with three lightning talks, so 3 times 15 minutes. And to make the flow smooth and nicer, if you have questions, wait until the panel discussion. At the end of the session, we have a panel discussion. I'm going to ask my questions, and you can also drop your questions as well using the chat of LinkedIn or the chat of YouTube or the chat of Twitch. So if you have any questions, keep a note when you're listening to any of the talks and drop them at the right moment. All right, so why I'm so excited today? Because I have a pretty amazing lineup, to be honest. We have today Mauricio Loriedo. So Mauricio Loriedo, I met him in KCD Austria. He was also at KubeCon, by the way. And he's going to talk about kubectl debug. So for any one of you who are willing to debug your pods in a Kubernetes environment, you may be interested of his session. So stay tuned. He will be the first speaker of tonight's live stream. The second one is Mauricio Salatino, Salaboy, for those who know Mauricio, very well known. He's a maintainer of Dapr. He's published so many books out there, and his session again will be very interesting because Dapr is an amazing project, and Dapr is providing observability. So I'm really, really excited to hear more about what Dapr can offer in the observability space, what we can collect. So that would be a great session from Mauricio. And last, we have Abdel. So if you running in Kubernetes environment, you may have heard about Abdel because Abdel is running an amazing podcast related to Kubernetes. And I'm really, really excited to have Abdel tonight with us. And he's going to touch base more on Istio. Istio is a service mesh and provide lots of different features specifically on the observability side. So without waiting anymore, I suggest that we should start with our first speaker of this tonight, which is Mario. Ho, 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 Mario, how are you tonight?
like an Italian in Paris, missing the sunshine. Yeah.
Sometimes you need to if you were living in south of France today, it was pretty nice weather. I mean, you see the sun, you see the beautiful landscapes, but it was windy, so you don't wear shorts at that time of the year for sure.
I need to discuss that with my family. Yeah.
So I see that you have a red sweater. So I guess it's the Santa Claus color, or is it just randomized, or is it?
Yeah, I think you will also see from my slides, it's kind of a Christmas version of the talk that I'm going to give. So
awesome.
Yeah.
So you know the rule. I will leave you the stage for 15 minutes. And yeah, let's share this great concept about debugging in Kubernetes. I'm very excited about that session. So see you in a few minutes. And the floor is yours, Mark.
Thank you, Henrik. and thank you for having me. Yeah, so my name is Mario Loriedo, and I'm going to talk about kubectl debug and something. So we're going to cover that, and we're going to also talk about something that, in my really personal opinion, it's just my personal opinion, is like there is something that is missing with kubectl debug. I'm sorry for all of those that call it kubectl or other names. So I'm sorry. I'm used to call it kubectl. So that's how I'll call it along the presentation. Just a quick intro for me. So I'm a software engineer at Red Hat, and I've been working for the last 7 years on cloud development environments on Red Hat. Multiple projects like 𝐁𝐿𝐥 and its product that is called OpenShift Test Spaces. But lately, so in the last 10 months, I've been working on the container runtimes, so mainly Podman, always for Red Hat. But today's talk is more about cloud development environment and specifically like debugging application running on Kubernetes. So yeah, let's start from kubectl debug. kubectl debug is, for those that do not know it, is actually a command for troubleshooting workloads, nodes running on Kubernetes. We're going to focus more on workloads for this presentation, but it can also be useful to troubleshoot nodes. How it works with this sidecar container concept. So it actually starts new sidecar container in your original pod or in a copy of your pod, and that container should have, so it's you can define the image used to start the container, the sidecar container, and that image usually you want that image to have all the tools that you need for debugging your application. So a debugger or whatever you actually need for debugging. So that's really cool. So I mean, it's one of the coolest command that you can use, at least as a developer that needs to debug stuff. So I've been really frustrated, and I've repeated those steps of debugging a lot of times when you have something. So you start an application on Kubernetes, and there is something that doesn't work, or you're waiting, and you start getting nervous, and you actually, the first thing you do instinctively is get pod. So it's basic information of pod. Is it running? It is still pulling the image. So is it creating? What's the status? If you don't get much information, you're gonna go with kubectl describe, and then if you want even more information, you get the JSON of version of the kubectl get pod. If you still don't have enough information here, you probably want to look at something different, like the events, and then also the logs of the application. Problem is, often you don't get a lot of interesting stuff from those commands. And the last thing that you can use is kubectl exec. kubectl exec as the problem that you actually need a shell. You need something that you can exec into your production pod. And often, if it's a production pod, it may not even have bash. So it makes it really hard to do a kubectl exec in this case. So kubectl debug instead is the most powerful probably of those. It's a little bit probably more complicated. So you need to actually specify a specific image that you want, a debugging image. So you need to have it ready. And then, yeah, you actually have access to your container. You can debug it, and you can see all the processes that are running in the container. So command. And actually, before I actually talk about what is missing, let me just do a quick demo about it. So let me make the screen bigger. If I try to see if I have a pod here, let's see. Okay, I've currently an example application, really simple Go application that is running on a pod in my namespace. And what I will try is I will do I will try to start a sidecar container for debugging. And to do that, I will use, let me show the script that I have. It's demo assets, and it's debug. Okay, so that's the command that I would like to execute. So it's a kubectl command, and as you see, the first parameter that I pass to debug is actually the name of a pod. In this case, the pod is the pod name is 𝐿_yet. Second parameter is the image. So I want to specify an image for starting the sidecar container. And that image, so the image will be Golang. It's really the simplest thing. Since I need to do debugging of a Go application, I will use that one. The third thing is I want to share the processes that are in the original container with the debugging container. So I will specify share processes in the command line. And the last thing is that I would like to do a copy. So I'm in the copy mode here. So I would like to do a copy of my original pod, start the same container, start the sidecar container, share the processes, and the new pod name will be 𝐿_yet debug. So the new pod here that I started. So let's just try to execute that. Okay, so now it started a new pod. He has started it with an extra container, and I'm actually now inside my debugging container, and I can do something like psef, and yeah, I can see my application that is running here. So this is cool. So I could probably even kind of look at the logs and those things. But the problem is, so at least my problem as a developer is that if somebody mentioned the word debug, I actually think that I will have access to an IDE, right? So I expect to have it so to have the a way to actually set breakpoints, to watch variables, etc. So everything you get on IDE. So this is not something that today is possible to have with the kubectl debug command. So that said, so I've been working on cloud development environment. So starting VS Code or IntelliJ in Kubernetes. With my team, the thing that we were excited when those kubectl debug and when the sidecar container were actually became GA is that we saw it as a natural opportunity for those cloud development environment to debug, so to target an existing pod and to actually start in a sidecar container VS Code or IntelliJ, so an IDE. And the idea was to actually develop a kubectl plugin, and that's the kubectl plugin. We call it debug IDE. So the kubectl debug IDE will have the same flag, the same parameter as kubectl debug, with an extra thing. So for now, it's like the Git repository, because you want the source code. So you need to specify to this command, you need to specify also the Git repository where actually the extension, the plugin, will be able to to clone, to do a git clone of the source code. So let's do a demo of that now. So let's go back to here. I'm still in the debugging pod. So I'm going to exit. I will actually look at what I have here. So yeah, I still have my debugging pod running. So I will remove it. So delete pod out yet, and here it should be deleted. Okay, so it's taking a few seconds. Okay, so it took some time to actually kill the process, but now we should actually have only the production pod. So we want now to do to use this this plugin. But if I try now locally, I try to do a kubectl debug IDE. There is no debug IDE currently. So I'm here on my on the Git repository. So on the local repository of kubectl IDE, and I will do go install of my Go application, the command, and that will actually do the build, and it will copy the binary in the Go binaries folder, so that at this point I will be able to, if I do like kubectl debug IDE help, yeah, it should be here now. So if for those that are not familiar with the kubectl plugin, this is actually just a binary that is called kubectl dash something, and in this case is the let's try to go bin kubectl. In this case, it's kubectl dash debug underscore IDE. So now that this binary is in the path, actually kubectl is actually going to call it once when I do the command, I call the command kubectl debug IDE. So this is pretty powerful architecture. So it doesn't we don't need to patch or do nothing more than actually just copy the binary in the path. So once I have that, so you see we're looking at the help. It has a lot of options because we want that to have exactly the same options as kubectl debug, but yeah, so those are, so we are not going to review that now. The simple demo that I wanted to show is like, let's go demo set. I had like kubectl debug IDE. Yeah. So in this case, it's exactly the same parameter. I changed the image just because I wanted an image that had Git and other stuff that will allow my VS Code to start easily. But beyond that, it's a pretty straightforward image. Then I still pass the share processes that is needed, because if I want to debug the process that is running in my production container from my sidecar container, I need to see the process so that my IDE is actually able to see it. Yeah, the copy to is the same option as before. So it's the name of the new pod. And then there is a Git repository that I specified. That's a new, so an extra, the extra parameter that is for specifying where do the plugin fetch the source code. Okay, so let's execute this now. Okay, so that's it's actually talking about that workspace. I will talk about that later, but it's customer source. So the plugin is creating a Kubernetes customer source that is called dev workspace. That is a customer source that's used with the dev workspace operator allows actually to start development environment on Kubernetes. So now that I have that, I can actually when the command completes, it actually return a URL, and so I can copy that URL. I will just make it here. Let me make it bigger. Can also go full screen. So as you see, so once I put the URL in my on my browser, I actually have VS Code that is started on in my browser. So the client is running on the browser, but actually the server, the VS Code server, is running in the container, in the sidecar container that is running on my cluster. This is the source code of the application that I'm actually running, and the application is already started. So I don't need to start it from the IDE. What I can do is that I can set a breakpoint and actually just attach to the process. So I will put debugging a breakpoint here, and I will go here, and I will call. So this is attached to local process. This is actually, so if you're not familiar with the debugging definition on VS Code, that's defined in a .VS Code. You have a launch JSON, and so launch JSON, you need that for debugging on VS Code. So there is this attached to local process that allow me to actually do the debugging. So let's right here. Okay, he found a process to attach to, and he has attached to the process. And now it should. He actually also stopped here at the breakpoint because so this function is tagged is actually called repeatedly. So we were able to attach to the process running on the Kubernetes cluster and being able to actually see the different variable that are here. So I could debug it as exactly with as I usually do on VS Code. So that really works really well. So that's about it for this demo. So let me just go on the slide. This is the kubectl IDE. That's how it works. So that then when you have the URL, you're actually able to start the IDE and to attach to a process that is running in the pod that you want to debug. So we have made some design choices. First of all, it's a kubectl plugin, and we wanted to actually support the same flags that kubectl debug has. Is part of the dev file that it's a CNCF project, and that's because mainly in the same organization on GitHub there is also the dev workspace operator that again is part of the dev file. That it's this operator that is a requirement to be able to use this kubectl plugin. So the dev workspace operator is an operator that defines a new customer source, the dev workspace, that allows to start development environment on Kubernetes. I've shown VS Code, but it's also possible to use IntelliJ, and we still need so there are a few things that we are working on. But it's really an alpha project. Yeah, that was my last slide.
Awesome. Because I was going to say,
Yeah.
could you start concluding, because you were I let you five. You were out of time, but I said you were at the middle of the demo. You were showing the debugging actually, and then I said I cannot stop here.
Okay.
So I let
yeah.
you finish the demo. Thanks you. So here I'm putting the QR code for the to the GitHub repo. So for those who are interested to learn more about the project. And I think it's amazing. I have a lot of questions from what you presented. Because here you use mainly a command line, but I was thinking or the other way of doing it. But I will keep that again for the Q&A session. So same thing, if you were listening to Mario's talk and demonstration, and if you have any questions to Mario, note it down, don't forget them, or drop them directly in the chat, but we will answer them, of course, at the end of the session, of the show, sorry, at the panel discussion. So thank you, Mario, for presenting this. It was 100%. It was super clear. So I think everyone understood the value of that. And see you later on for the panel discussion. And let's move on to the next talk, which is this next speaker is going to be Salah Boy. So for those who doesn't know who's Salah Boy, wait a few seconds and you know who he is. Hey,
Hello.
How are you?
Very good, Santa. How are you?
I'm very excited to hear more. I heard that Dapr is offering observability for Christmas.
Let's see how that goes. We at Dapr, we're passionate about that observability as well. So, but again, coming from a different angle, I really enjoyed Mario's presentation about debugging containers. That's super cool. And I'm a developer myself, so I enjoy kind of learning about these tools and using these tools mostly with my IDEs that I'm used to do my work, right? Like VS Code or IntelliJ. I think that's perfect. I think that I'm the right audience for that presentation.
And also for just to remind for those who never heard about Mauricio. So
Yep.
Mauricio is like I mentioned before, a maintainer of Dapr. He's invested in many different working group in the CNCF works environments, platform, the Knative, and others. And what he has, you may have heard about Mauricio, is this book about platform engineering. He has an awesome book about platform engineering. So if you want to learn more about it, I really recommend to have a look at this book, which is really good. All right, so Mauricio, I'll leave you the stage. So you have 50 minutes, and
Great.
I'll touch base in a few minutes. Then see you.
I will put the timer and I will get started. Yes, so welcome to my presentation. It's titled Building Observable Cloud Native Applications with Dapr. As Henrik mentioned, I'm a maintainer in the Dapr project. I've been working as a developer for a long time and just jumping between different CNCF projects. In this case, I would love to talk a little bit about Dapr in relationship with observability. In order to talk about Dapr, and before talking about Dapr, I just quick presentation about myself. As Henrik mentioned, I published a book titled Platform Engineering on Kubernetes, where I cover a bunch of different projects, not only on observability, but CI, CD, GitOps, and a bunch of other things that are related to Kubernetes and Kubernetes adoption, mostly covering from a developer point of view in the sense of how these tools help me to deliver more software. So if you're interested, check it out. I'm also running my blog for the last 15 years, which is salahboy.com. That's my nickname, and you can find me in all social networks with that nickname if you want to send a question or ask or give me a comment about the book or whatever other topic you want to discuss. So as I was saying, if I want to talk a little bit about Dapr, I need to talk a little bit about distributed applications first. In order to do this presentation and for KubeCon as well, I presented a small demo showing two separate applications that are basically highlighting common interaction patterns between distributed applications. These are just two services, a producer that produces information and a consumer that consumes information, basically. And then just showing the two interaction patterns, which is one with the synchronous approach using mostly HTTP. That's kind of what developers know how to do, send requests via HTTP, pretty easy between different applications. And then if you are building more event-driven applications, you might use some asynchronous method or mechanism like using a message broker, right? Where you place a message into the broker, and then the consumer app, maybe it's not running now, it runs tomorrow. When it wakes up, it will go and consume some messages from there. So the life cycle of the producer and the consumer are a little bit decoupled, which in the case of the synchronous interaction, both application needs to be alive, and you need to make sure that they can reach each other via the network. As I mentioned before, I did a presentation at KubeCon for this, and there is an example application that you can run in your Kubernetes cluster. That's the GitHub URL on top. I'm pretty sure that Henrik will share that link as well. But if you want to run this, you can actually run it. And the application, let me quit my presentation view here. It looks pretty simple. It just demonstrates the interaction patterns between these two services. You can see that I can send synchronous requests to the consumer application here on the right, and I can send asynchronous communications to the consumer app as well. These both work kind of different. Like if I click here, I send a request, and then I get the thumbs up when the request got processed correctly. And in this case, I send a message to the message broker, and I get the ACK as soon as I put the message in the message broker. And then when I consume it here, I see the other envelope popping up here from the consumer side. Because it's a distributed application, right? Things can go wrong. So basically what I will do here is just touch these buttons, which will start basically producing errors. In this case, I'm sending a request, and you can see that like the requests are not reaching to the consumer side because they are just broken. The consumer app is returning a 500 error maybe. And the same for the asynchronous approach. I can see here that I'm getting the ACK from the message broker. In this case, the message broker is not broken, so I can place messages. But on the other side, it's failing when I'm trying to consume these messages, right? And I will just revert this back so I can just send more requests now, and they just get processed correctly. So simple architecture, simple interaction model, both synchronous and asynchronous. But this is to prove a point that when we build applications, when we build distributed applications, we will be dealing with this a lot. And as developers, we will just be doing pretty much this, sending requests, moving data around different services and different applications. I'm using 2 services here. In real life, we will have hundreds of these, and we will just need to communicate all of them in a resilient and an observable way. So if you're building cloud-native applications, it's quite common to use some sort of proxy to delegate the responsibility, for example, about resiliency policies, retries, circuit breakers. If you are working kind of like in the cloud-native space, using something like a service mesh, like Istio or Linkerd, you have probably seen these before, right? And the idea here of the proxy is you delegate to the proxy the responsibility of implementing these mechanisms, so we add resiliency and we add like robustness into our application without changing our application code. This proxy will deal with managing the traffic between the 2 applications in this case, and if something goes wrong, it will automatically trigger retries or circuit breakers to avoid like bigger issues. Because you have a proxy that it's looking and dealing with traffic here, you can add the observability side of things, right? Like again, we can observe the traffic that is going through the proxies and across applications, and then we can start understanding what our applications are doing. That's a very, very common pattern. If you have been working with Kubernetes, you probably have heard about the sidecar pattern, which is pretty much how these proxies gets implemented when you're deploying things on top of Kubernetes. This proxy will be very, very close to your application, so there is no network latency between your application and the proxy code. That's the whole idea. And that's why I wanted to talk a little bit about that, distributed applications, the idea of using sidecars, because Dapr is a CNCF project that just graduated this year, so we're extremely happy about this. It's a very mature project that basically used this pattern, this proxy or sidecar pattern, to provide APIs to developers to build distributed applications. So that's something that usually service meshes will not do. Service meshes will try to be fully transparent for your applications. They will not ask you to do something different in your applications. They will deal the traffic at the networking level. In this case, we are offering application developers some APIs that they can use to implement some of the behavior that their applications are implementing. Dapr stands for Distributed Application Runtime, and basically we use this proxy model to expose these application-level APIs to solve common distributed challenges. For this example that I've just shown you, like the consumer and producer, we're using 2 different Dapr APIs. That basically means that the producer application is using 2 APIs, very specific APIs, that are exposed in this proxy that the application can call to do service-to-service invocations and asynchronous communications without knowing, for example, which infrastructure is available to perform these requests. And again, because we have APIs, as soon as you have APIs, you can implement cross-functional concerns such as resiliency, observability, and security. And that's why we are extremely passionate about observability because we integrate with OpenTelemetry, and we expose all the stuff that OpenTelemetry allows us to expose, so you can get observability on top of your applications. So just to recap, if I have like my producer and my consumer, I will basically, if I'm running on Kubernetes, I will install the Dapr control plane, and the Dapr control plane will automatically inject these proxies into my application pods, basically. The big difference here, again, with the service mesh is that we are exposing APIs. Again, as I mentioned before, this basically means that the producer application will be using 2 different APIs, in this case, publishing events and invoke services, in order to use this functionality that is exposed by the proxies. The idea here, again, is it doesn't really matter which programming language are you using in the producer or on the consumer application. You will always call these APIs that are exposed via gRPC or HTTP from any language of your choice, and you will be able to consume these behaviors that are implemented by Dapr. Important on the publish event here, it's much more clear than invokes like a synchronous invocation between services, is that you need a message broker. You need some sort of infrastructure that actually implements the message broker itself. And for the example that I've just shown you, I'm using RabbitMQ that it's running on Google Cloud in a GKE cluster, but actually Dapr allows you to, as an application developer, only understand how to use the publish event API, and then the operation teams or the platform engineering teams will configure the available infrastructure. The whole idea behind that is that I can go and change now RabbitMQ for Kafka or use some managed service like Google PubSub or Amazon SQS, and I don't really need to change my application. It also removes the need for the application to have a dependency, in this case to RabbitMQ, right? I don't have a RabbitMQ client to connect to RabbitMQ inside my application, because now that's the responsibility of Dapr itself. Dapr exposes an API, the API is implemented by different providers, and the application developer only need to learn about how to request to these APIs. So from as I mentioned before, the Dapr sidecars exports all the OpenTelemetry data. And using kind of like, in this case, I'm using the Elastic dashboard, but you can use any OpenTelemetry, dashboard of your choice. You can see here that I'm showing you here like the producer application, which is a Java application, then the Dapr sidecar for the producer application, the Dapr sidecar for the consumer application, and then the consumer application that it's Java. These applications can be in any languages. They will all have the same APIs available for them to consume and to implement these interaction mechanisms. The same happened with traces. In this case, I'm just showing the trace of sending messages via the message broker. So you can see the application placing the message into Dapr itself, Dapr putting that into RabbitMQ, and then from the consumer side of things, consuming the message from the consumer. The same with the synchronous request. You can see all the traces here like that are propagated and aggregated, so you can actually understand the full trace of the request and where it went through, all the hops and all that stuff. And we are doing that out of the box. But what I wanted to show you, which I think it's different from kind of like what a service mesh perspective you will see, which is kind of like the low-level traffic, is that because we are exposing APIs, we have created this project that runs on top of Dapr, and any Dapr user can use it. It's called Conductor, that gives you observability in different places. It gives you observability on the Dapr control plane itself, just to make sure that it's up to date and everything is healthy and running from the Dapr perspective. But more importantly, from the application point of view, it will show you which applications are using the Dapr APIs and interacting with Dapr in some way or another. And then what you can see is their interaction patterns as well. So what I'm showing here is the producer application is it's communicating with the consumer application via 2 different ways. One, the synchronous way, which is HTTP in this case, it goes straight away. And then the asynchronous way that in this case uses RabbitMQ as a PubSub implementation. This is kind of like, I think it's important to understand that this is a high-level view of the APIs that the application is using, which is pretty different again from the traffic that it's being exchanged between the applications. And this gives us kind of like some interesting details. Of course, you have all the telemetry about like CPU and memory. But I think that most importantly, the thing that I really wanted to show here is kind of like here, like very important, like this green graph here. It's basically showing that my producer application is calling this API in the consumer application. It's already filtered because we know which APIs Dapr is exposing and the interaction mechanisms between the applications. The same here for publishing events. We can see how many events are being published using the publish event API. And we can see which application is doing that and which method is using and which protocol in this case that's going via gRPC to be more efficient and to have bidirectional subscription for live events. And finally, one more thing that I wanted to show is the resiliency stuff that it's built out of the box here. Again, I caused some issues. So you can see here like the circuit breakers opening up and closing up when things are going wrong. So again, from a more high level perspective, you can see that breaking down by APIs, which is again something that if you are just looking into the traffic itself, you will need to correlate and aggregate. This is done out of the box because we know which APIs the applications are using. Finally, because I know that I have 1 more minute or so, I wanted to mention something that it's really important, at least something that I enjoy a lot doing at KubeCon. We did a presentation with someone, with Jonas from Elastic, about like the fourth pillar of observability, which is something that it's called profile and profiling. There is a YouTube link there for the full presentation because we went deeper into how we can actually profile the entire stack when we have distributed applications, which I think it's really important. The more tools that we start using and combining in order to get our distributed applications right, the more difficult it is to identify where the problems are. Maybe the problem is not in your applications, and maybe it's one of the projects that you're using. So we wanted to make sure that we do like a full profiling on all the tools that we are using and have an understanding of what's going wrong when things are going wrong. And I have like a video that I would just not play all. I would just jump somewhere just to show here like the flame graphs. And basically what the flame graphs were showing is that, again, we can profile everything from our applications to Dapr itself, to Kubernetes itself, and to also like, the machines where Kubernetes are running, like the kubelet and everything else you can see here, like some time is being used by Dapr, and that's all good as soon as it's efficient and as soon as it's giving us some functionality. It's all good. But again, if you're interested in profiling across different tools and getting observability down to that level where you want to understand the full stack, how it's working and where it's actually consuming CPU or memory, I think that it's a good talk to take a look at. I think that I will just leave it at there. Again, the full idea of this presentation is just to mention to you Dapr and what it does with a very, very simple example that you can run in your own cluster. This is the URL of the repository, Salaway at KubeCon-2024-NA. You can run it, you can experiment with it, and if you have any questions, feel free to reach out and send me a question or right now or via the social networks. Henrik, I think that's pretty much it.
This was amazing. No, I love it. Love it. And you didn't mention, but I'm sharing the link to your blog if people wants to have more details about all the different work you've done. You usually publish a lot of things on your blog, so it's a really good link to share. I have tons of questions, but again, I won't ask them right now because you've got many different things, and then suddenly I say, but what? Yeah, never mind. I will drop those later on because otherwise it will start a conversation that I will not able to control at that stage. So it's preferred to leave it later on. So thanks a lot. I love that. I love the presentation. And for those connected, if you have any questions to Mauricio or Salboy, drop your questions on the chat. So LinkedIn, Twitter, not Twitter, sorry, LinkedIn, YouTube, and Twitch. And if you have any of those questions, we will answer them during the panel discussion. So the last presenter of today is Abdel. So see you in a few minutes with Abdel. Oh, Abdel, how are you?
Good, and you?
Very, very good. I'm very excited to see that you're wearing one of the mascots of Kubernetes.
Yes, VP, if everybody is getting the reference.
And for those who never heard about Abdel is running an amazing podcast. So if you are into Kubernetes or service mesh or anything related to those areas, you should definitely check Abdel's podcast because it's really interesting. There's always the latest and greatest about those topics. So I would recommend. And the funny story about Abdel, he started he's from Morocco. We had a lot of chats about it because Morocco is an amazing country, and he started his career in Morocco, and then he moves on to Belgium, and then he moves to Sweden. And my next question to you is, So you're moving north. So what is the next? You're gonna end up in the North Pole with me, Santa? Is this what you're
Yes,
saying?
yes, I'm joining you on the North Pole next year.
So you're planning mainly on working on Kubernetes, I guess, for GKE.
Yeah.
What are the main topics that you're working on?
Well, a lot of AI, but a lot of my background is in networking, so I do quite a lot of things with networking and security. But a lot of AI these days, and a bit of service mesh. So
Cool, awesome.
Yeah.
And that's in fact one of the topic of today's talk.
yes,
So you know the rule. I'll give you 15 minutes, and I will see you in 15 minutes, and then we can start actually asking questions. That's the most interesting piece. So leave the stage to you, and see you in 15 minutes.
so I have a reputation of speaking fast. So let's see. I don't really have any demo or anything. I just have a bunch of slides. I want to talk a little bit about Istio in the context of observability, or service mesh in the context of observability. So I'll spend a bit of time explaining what service mesh is for those of you who doesn't know, and then talking about what service mesh and specifically Istio provides in terms of observability, right? So I'm not going to bore you with the details. You all know that the whole point of service mesh is to makes microservices better. Why? Because everybody's building microservices these days. Why? Because monolith sucks, and there are reasons why they suck. And we've been moving toward microservices. I think I'm going to stop here because it's very important to define what a service means in the context of microservices. And when it comes into service mesh, it's very important to understand the definition of service. A service is basically a deployable unit of software that has a specific business logic that does one specific thing. In the context of Kubernetes, a service does not necessarily map to a container or to a pod. A service can be represented by multiple containers or multiple pods. So if your microservice is a payment microservice, that's essentially a service. For the rest of this presentation, it's just like a single thing that has a specific business logic. That's basically what a service means. So taking an example, if you have two microservices or two applications or whatever you call them, each have a specific function or specific business logic. You put them in containers. That's what we are doing these days. And you need to make them talk to each other. And this is where I will pull out my developer hat and put in my network hat and go down a little bit to the lower levels, which is the part where usually developers get a little bit scared and confused, but I'll try to guide you through it. So stick with me. Your services typically talk over APIs, right? They talk to each other over APIs. If you are not doing APIs or PubSub or any sort of queues, then you're probably doing something wrong. What do you need? You need service discovery. You need service A to find service B and vice versa. You need traffic management. You need probably some security. And the most important thing is you need observability. So realistically, your services will have an identification, which is important for security. Authentication, authorization, right? They will have some sort, or they need some sort of network resiliency. Regardless of how much you would like to believe in fairy tales and unicorns, the network is not always reliable and things will break. So you need to be aware of that. You need some policies, quotas, rate limiting, stuff like that. And you need observability across all of this, right? And so the key here is that your application is just a very simple component in this entire stack of things that your service or your microservice needs to execute or to have or to function. And that's where service mesh comes in. What a service mesh does really, it allows you to take your application and decouple it from everything else. So if we say that a service or a microservice is the application plus everything else that it needs, the API, the security, the observability, the network resiliency, and the policy, why don't we decouple these two things? And what we can do in this case is we can keep your application with its API inside one container and then delegate all the other functions to another container, which in the context of Kubernetes, we typically call it a proxy or a sidecar. It's just two containers running inside the same pod. One has your application, the other one has everything else. This is another representation of how these two things looks like. And so a service mesh is essentially a tool that provides you with a transparent, language independent or language agnostic way to automate what we call network functions. Because pretty much all these functions that I talked about, the resiliency, the policy, the security, the observability, these are network functions. These are network level functions that your application shouldn't care about. So most service mesh tools that exist today in the market follow a very basic architecture, which is a control plane, data plane kind of architecture. So the control plane is the component that manages the entire thing. The data plane is typically a proxy that talks to the control plane, asks the control plane to do things, and reports things to the control plane. And I know that I'm using things in a very hypothetical, high-level definition, but I'm going to get to details at this stage. You see here that we have different colors to represent the different kind of functions. We have two, like, we need to execute these network functions on both inbound traffic and outbound traffic, ingress, egress, whatever you want to call it. I'm going to get into that in a moment. So one of the things that Service Mesh does is, because we're able to decouple the network functions from the application itself, then we're also able to get some sort of uniform observability across the board at the network layer. And those network observability functions or features are given to us by the proxy. Back to this slide here. This proxy here is the thing that will essentially sit on the network. It will see all incoming and outgoing traffic out of your application. So it has observability because it's literally able to observe things, right? One of the main reasons I like the term observability is because it typically means that there is a component that is able to monitor, to watch, to observe what's going on. In our case, it's a proxy. Sometimes it's an agent. Sometimes it's a process. Whatever that thing that does observability, it's just an extra component that sits outside of your application that monitors, observes what the application does, and collects information and ship it somewhere. So Istio. Istio is one of the many service meshes that exist today on the market. It's probably the most mature, and it have been going through a huge transformation to change its architecture from sidecars to sidecarless, which is what we call ambient mesh. For the context of observability, that doesn't really change much in terms of what kind of metrics and logs we're able to get out of our applications. But I'm not going to go too much into details what ambient mesh is and what the future of Istio is. That's a talk for a different topic. That topic for different talk, sorry. But you can go look into ambient mesh if you want to see where the future of Istio is heading. So Istio was created by Google, IBM, and Lyft in 2017. It runs on Kubernetes natively, but it's also able to extend toward virtual machines. It works mostly on HTTP and gRPC traffic, so aka layer 7 traffic, and it's adopted across a lot of organizations. And there are even companies today that has basically as a business model to provide Istio as a service. It has, again, a control plane, data plane architecture. So the control plane is a component that we call typically Istio-D, which runs in a namespace in Kubernetes. It's the Istio's data plane is a proxy called Envoy, which is a stateless gRPC-driven proxy that sits next to your application, talks to the control plane over a specific protocol, and implements all these network functions that we talked about. So the network functions would be security with MTLS, mutual TLS, monitoring, policy enforcement, routing or traffic management, etc. It has two extra components, one called the ingress gateway, one called the egress gateway. These are implementation details. I'm not going to go into details that much in this presentation, but just remember, your application sits here, what we call service A and service B, and the proxies implement the network functions. So now let's get into the weeds. Observability. Basically, Istio offers three types of observability components. It offers metrics, distributed traces, and logs. And for the metrics, Istio has a very specific focus on what we call the golden signals, which are the 4 golden signals. And those are the golden signals that have been defined in the SRE book, the Site Reliability Engineering book, written by Google. Latency, traffic, errors, and saturation. And I'm going to talk about this in a moment. So let's start with the metrics. There are 3 types of metrics in Istio. There is service level metrics, proxy level metrics, control plane metrics. Let's start with the basic ones, control plane metrics. These are basically the metrics coming out of the control plane itself. CPU memory, CPU memory utilization, etc. Istio-D itself is stateless. It doesn't have state. It stores everything in etcd. So you can scale horizontally Istio-D or the control plane. So if you have more services in your cluster, this can be scaled and put behind the load balancer so that your proxies talk to the load balancer, which then distribute the load toward the control plane. So these are the basic ones. Proxy level metrics are coming out of every proxy. So these are things like latency, errors, HTTP responses, HTTP incoming requests, etc., both for ingress and egress traffic. Now, here is where there is a very important distinguishing to make between proxy level metrics and service level metrics. In Istio world, a proxy exists next to every single container of your application, regardless of how many containers of your application are running. So let me repeat that. Every container of every application has a proxy attached to it in the sidecar-based architecture. In the sidecar-less architecture, that's a different story, but I'm not going to go into details. Which means that if service A has 5 replicas, there are effectively 5 proxies, right? So every single proxy will emit some sort of metrics. So these are proxy level, fine-grained metrics coming out of every single proxy. Now, to correlate those to service level metrics, if service A is an application, a payment service that has 5 replicas, what ideally I want is I want an aggregate level of metrics across all the instances of my service, right? And so that's where service metrics come into play, and that's where those 4 signals I talked about come into play. So Istio has a way to aggregate metrics across all the instances of a specific service and report those as a single component. So it will give you latency for service A, traffic for service A, errors for service A, saturation for service A. For each of these metrics, the way they are calculated is different. Latency is typically a cumulative, traffic is a cumulative, errors is a percentage, and saturation is also a percentage, right? I hope that makes sense. Then Istio comes in with Prometheus by default. So all these metrics can be exported to Prometheus, and then you can consume them through Grafana. There is actually a specific Grafana dashboard that when you're installing Istio, you can just enable it via flag, and then you get all these dashboards out of the box. Distributed traces, pretty straightforward. Because the proxy sits between all the applications in the cluster, they're actually able to generate trace spans. So all your application has to do is when trace span is available, just pass it as part of the context to the next service. And therefore, you can get out of the box trace spans generated by Istio itself. It supports a bunch of backends, Zipkin, 𝐤𝐤𝐻, OpenTelemetry agent, etc. And then you can visualize those in whatever. This is 𝐾ALI is the most no, this is not 𝐾ALI, sorry. Yeah, it's 𝐾ALI, I think. The most popular one. So there is also a 𝐾ALI installation that you can deploy inside Istio, and it gives you traces, and you can look at them like this, like what you're looking at. There is also a topology graph in 𝐾ALI. You can actually click a button, which is this little button that you see over here on the left side, which I don't have a screenshot for, sorry. And then you can get a topology graph. You can get like a full graph of which services can talk to which services. Then the last thing I'm going to talk about is access logs. So access logs are essentially audit type logs. If you are using a cloud provider, there are audit type logs that can tell you which service called which service, when, and which method. You can see here that the way to enable them, there are 2 ways. There is a telemetry API in Istio itself, which you can just create an object called telemetry, and that will enable logs. Or you can do it during the installation using this configuration on the right side. And then it will generate logs like you see in the bottom. You get like a status, you get the type of request, you get the kind of request, and then you get like IP address, port, source destination, all that stuff. Now, I added one more slide, which is my last slide. I think that it's important when we're talking about what Istio can do for observability is to talk about what it cannot do for observability, right? And there are 2, and I am missing a third one here. It cannot do business logic observability. So if your application have very specific business logic metrics, you cannot extract those through Istio. You will have to export them and consume them on a different way. It does not export or look at workload-specific observability. So any custom metrics exported by your application. And the third, which I forgot to add, is it cannot do UDP TCP traffic. It can only do HTTP and gRPC traffic. So it's very important to know what this thing cannot do. And with that, that's it. That's all I have. Thank you. I hope that was useful. And I think I did not use all the 15 minutes.
Yeah, you were super efficient. You didn't talk too fast. And that because I know that sometimes you go very fast when you present topics, but you were very smooth. And for those who were putting some comments, no, it's not Pikachu. We'll discuss.
Come on, people.
It's a different persona. For those who knows the different people icons from Kubernetes, there's a giraffe, and this is the costumes for PV.
Yeah.
All right, so thanks, and let's take a 2 seconds break to finally start the panel discussion, because I have a lot of questions, by the way. All right, so first of all, thank you for taking the time, Mauricio, and Abdel, to build those slides and take the time to present, to wear the PP costumes, to wear the Salboy. We don't see his T-shirt.
You see my T-shirt? Yeah, there you go.
Yeah, it's a Christmas T-shirt as well. So he
It's
made
Christmas
also,
T-shirt.
and Mario made also the red shirt for Christmas. So thank you all of you. So I really enjoyed the three talks. I think it's there was a connection between each of them, so I think that was make a smooth transition between each of them. And again, for those who's listening, if you have any questions to any of the session that you've been watching, drop a comment. And for those who are watching it offline, so because it will be available offline after this live stream, you can still drop a question, and I will forward it to the right presenter, and I could then reach out to you back with the answer. So, like usual in the panel discussion, usually I cover in each session one by one. So we'll start with the first question that I had for Mario, then move on to Mauricio, and then finish by Abdel. And of course, if you have any questions to any of the topics, I will ask also for you guys if you have any questions, because it makes more sense that we start like a discussion. So Mario, first, thanks. So I remember when we were in KCD Vienna, you explained the project, and I was like, wow, this sounds like will save so much time and so much pain that sometimes we're facing when we're dealing with Kubernetes. Say, oh, there's a bug I don't understand, and then you always say, oh, if I had the chance to debug, then I would understand. So I love it. And so you mainly presented the kube debug, and what I wanted to more is like you mentioned it's injected sidecar. So where are you heading to in this project? Are you planning to side with the dev workspace operator to inject like a specific CRDs or objects where we would have the options to enable without using any kubectl commands anymore, because kubectl command could be intrusive, and depending on the environments, you're not authorized to use those type of command line, because you just rely on CRDs or Argo CD objects. And I was wondering if what is the next steps after providing kubectl ID?
Yeah, thank you, Enrique. So I think that's a great question. kubectl plugin allows us to actually prototype fast. So it was the easiest thing to do. So it's really straightforward to develop that. But at the end of the day, that's just one of the clients that talks to the dev workspace. So that creates those dev workspace customer sources. So we have so there is of course a Red Hat product that you deploy on OpenShift that is called DevSpaces. That is a UI that allows you to debug, so to actually start development environments. We don't have yet an option to actually select a pod and debug that pod. So for now, DevSpaces is just you select a Git repository and you start the development environment with that Git repository, and then you can debug your application. You can build and start and debug your application. So the idea here would be either to integrate that functionality in DevSpaces, the product that is on top of OpenShift, so on top of Kubernetes, or to actually just have that integrated in the console, in the Kubernetes console that OpenShift ships. And that also, so I'm talking about Red Hat products here, but those things to get into the product need to go in the upstream projects. And for DevSpaces, this is like 𝐿𝐴 is the upstream project. So we've been discussing. So we are prototyping these things with the kubectl plugin. That I think it's also the easiest way for developers to try it out, because you don't need to. I mean, as a developer, so installing it really requires you. So the hardest step is to deploy the operator in your cluster. This is like the most complicated things. But if you have the OLM, so the operator lifecycle management already installed in your cluster, is really straightforward to install it. So yeah, I hope that answered the
Yeah, and in fact, I had another question right to that, because I mean, here it seems that it's like a strategy for Red Hat, because it's going to be mainly focused to provide this type of features in Red Hat's tooling. I was really hoping that this initially will be mainly available in for larger public for the open source world. But I guess with the kube idea, at least you were making a step forward. But I had a question, because usually in OpenShift, they're providing more security on top of the pods, so you have more security context, more things. So how would that happen? Would you required to run it in a specific mode, because I guess using those type of debugging will require some specific privileges that are not given by default on OpenShift, or what is the current idea on that behind the scenes?
No, that's so. Actually, my demo was I was running on OpenShift. So there is no. So you can start. So it's anything you can do with the kubectl debug command is something that you can do with my kubectl debug IDE. So it's just a matter of starting VS Code instead of just starting a sidecar container. So I'm just starting VS Code. So it doesn't need particular security requirement, except if you, for example, if you need to, if you want to run, so to start a container in your development environment that is already running in a container, so running a container inside a container, those things may require some extra capabilities if you want to build a Docker file. So those things may require, but in general, if you just need to run your IDE, you don't need specific capabilities.
Okay, cool. Thanks. Mauricio or Abdel, do you have any questions around the topic?
I really like that tool. I just need to play more with it. So yeah, no, I'm a big fan. So I'm just going to probably send you some questions, Mario, whenever I have them. I encourage people to send Mario questions if you have about that tool, because these tools are super interesting for developers. So I can see myself using this a lot.
Thank you, Mauricio.
Abdel, do you have any questions?
I didn't have a chance to play with the tool that much, but my question to you, I think, is more not hypothetical. It's a philosophical question. How much do you think, in reality, in production, people run non-distroless containers, right? I know that there is the theoretical part. This is what we talked about in terms of security best practices. You shouldn't have a container that has a distro inside. So no kubectl exec, no whatever, right? But in reality, is that the majority of people don't do it, or the majority of people don't care?
So I think this is something. So let me put it in another way. So I don't think I'm legitimate to provide an answer on that question. So meaning how many people, I assume that most people use distroless for running workloads on so their production workloads, and so that's why it should be why kubectl debug is interesting, because that means so yeah, I assume that. But so the reasoning is that cloud development environment are popular today, so they're getting popular. So the idea is, but what you really want, if you have something that is already running on Kubernetes and you are able to start an idea on Kubernetes, is to kind of link the two. So I was interested in that use case. That for me was an interesting one. Then I don't know if actually there are more people that actually can debug without the sidecar. So that's honestly, I cannot answer that.
All right, cool.
All right. So if there's any other question, let's move on to Mauricio and Dapr. And you started with the exact thing that when you started the presentation, you brought exactly the question that I had in mind. You
Great.
said there's service mesh,
Mhm.
and then there's Dapr, and I said,
Yeah,
okay,
yeah.
if I use Dapr with the service mesh, what will be the consequences?
I think that like you will be happy because those tools can work together. But unfortunately, you will probably have two sidecars.
Yeah, you have two sidecars, and then you when to do a communication, you do service A to the Dapr proxy that goes to the Dapr that decides which backend should be reached out.
Mhm.
So then is this communication between Dapr will be also managed by service mesh, which means if I got a trace, I will see service A, Dapr proxy, then service mesh, yeah. So then the
Not
actual. So,
not right now. Not right now. I think that that's kind of like where the problem be like start becoming, right? Like it can become a problem if you are not using the right combination and the right configurations. So if you use the Dapr APIs from the application point of view, you will go only through the Dapr sidecar, right? And the communication between the sidecars will be internal to Dapr. Like
okay.
nothing else will be looking into that. Now, that's the main reason why I started having some conversations with Envoy, for example, just to see if we can start like creating kind of like a single binary that we can use. Because something that we don't do, for example, at the Dapr level in the Dapr sidecar, we don't do traffic splitting and traffic management in general,
Yeah,
which
makes
is
sense.
something that that's something that service meshes do a lot, and they do it pretty well. So we just don't want to do it there. But
Yeah,
unfortunately, there is some overlap there.
yeah, but also there's something that that Dapr requires that Istio or service mesh doesn't require, is that if you want to use Dapr, then in your code you need to use the actual Dapr API to say, oh, I want to send a message, or I want to send an API call or whatever, and then it's the actual proxy that says, oh, so today my API or my like you said in your example,
This
today
broker,
I'm
yeah.
using RabbitMQ, tomorrow I want to disconnect it and plug it to Kafka, and there's
Mhm.
no differences in the code perspective because you're removing that dependencies from the code, which I think it's just an amazing feature, by the way. But that's, I think, it's the major differentiation between you and Service Mesh, where you are more in the code itself.
I think that that's the main thing, right? Like we go closer to the application developers. We try to help developers to be a little bit more agnostic about like the infrastructure that they are using, but also how do they implement like common distributed application challenges. I didn't show during the presentation. I showed just two APIs, the service-to-service invocation and the PubSub API. But Dapr provides some other very interesting APIs, like for example, an API for doing distributed logs, right? Like if you want to do distributed logs nowadays with different programming languages, you will choose different libraries to do that, and then you will need to coordinate that across different applications, bring new components in to support like storage of these logs and all that stuff. With Dapr, you just have an API, the developer use the API, and that's pretty much it.
A small comment from Mark Thompson, so a good friend of mine, saying that I think people like Dapr just because it's simple compared to Service Mesh. It depends. I think. I think the. Oh, sorry. I think it depends of the service mesh itself. I think once you're used to service mesh, then it sounds very easy. But yes, the first time you touch service mesh, say, oh, and then you've been sucked into another world. It's like Alice. I don't remember how the name of this.
In Wonderland.
Yeah, Wonderland. Yeah, you start you run in the rabbit hole, and then you're arriving in a really strange world as to start, but then it's a wonderful world.
I think that's. I think. Even if Dapr and Service Mesh can hypothetically live together, we shouldn't compare them simply because they're not. These two tools
Agree.
are not built to address the same personas.
Agree.
Istio or Service Mesh is an infrastructure component. It is not
Yeah.
a developer thing, right?
It's more on the networking as well.
It's a network thing, right? So they're not addressed to the same people. Like in an ideal scenario, a service mesh should be transparent to developers.
Yeah, agree.
Awesome.
So,
Completely. And there's a project that I discovered at KubeCon, and I'm going to say hi to to Laurent Baudou from Microx. So Microx is focused on mocking. And then this is when he presented the project, I said, oh, this is the wonderland for between Dapr and Microx. Then but then you just simply connect Dapr and says, today I'm using Microx mocking instead of the service B, and that's it. Your test is in place. So I think there's a I really
Synergy there.
want to really see this collaboration between both projects, because I think it's gonna just
It's coming.
simplify performance engineering tasks, testing tasks, or whatever that we have to do when we deal with services, for sure.
It's coming. It's coming in 2025. So just keep an eye
Oh,
there.
it's already
coming.
Christmas. Is this what you're saying?
Yes. Early Christmas present for you. Yes.
I had another question, because you brought something and I watched it and I was like, "Whoa, what's that?" So the Dapr observability, you mentioned a UI, and when I watched it and I said, "Wow, this sounds very
Mhm.
cool and I love it," and I was wondering a few things about this.
Yep.
The first thing is it a part of the Dapr project, or is it Dagrid who provided how
Yeah. So we are very passionate about like Dapr developers. So we have created this product. It's a product but that developers can use for free. That it's called Conductor. That you can just plug in into your Dapr installations. That will give you management on the control plane, but also observability on kind of like what the Dapr APIs are being used. It's kind of like some sort of like advanced dashboard for Dapr users that they can use if they are running Dapr on Kubernetes.
Okay, and then the thing when you showed it's showing the CPU. There was, so are you
Mhm.
collecting straight to the pod, or are you also relying on exporters to get that data? Because you were seeing in those UI there was some CPU
Mhm.
memory usage from the service itself, and I was
Yep.
wondering if you were had to connect Conductor to get that data from other exporters.
So you can get that data if you configure the observability stack on Dapr itself. Like you can
Okay.
just use Open Telemetry and just get it out of the box, like it's there. Like the data, it's not only for this UI, but this UI is actually getting that data from the Dapr control plane and just collecting from
So
all
at the
sidecars.
end, all the data that Dapr is producing,
Yep.
and that you're able to show in Conductor, you
Mhm.
can basically ingest that anywhere in the entrance, for example, and then
Yep.
build the similar use case. Awesome, I love
Exactly.
it. I love it.
Yeah. Everything is Open Telemetry. Everything will work for everyone. We are just building a tool that will simplify some things for management and for observability as well.
Awesome. Mario or Abdel, do you have any questions to Mauricio?
I have actually. So I wanted to learn. So I don't know Dapr, honestly. I haven't tried that yet. But I was curious about like the developer experience, because you are hiding infrastructure, and that is really cool. But on the other hand, if I'm bootstrapping my project, or actually if I want to locally test,
Yep.
Do I need to use, for example, you show like the asynchronous communication with RabbitMQ. Do I need to deploy RabbitMQ, or can I just change it for my development purposes? And so how do I manage that part?
Yes. Okay. So that question has very, very different answers depending on the programming language that you're using. And I assume that you know Quarkus and you know the Java community. I don't know, like coming from Red Hat.
Sure.
So we have kind of like different experiences for different languages. Dapr is very well known in the .NET community. So they have something called Aspire that basically allows you to bootstrap kind of like a local version of Dapr that basically will connect to in-memory infrastructure or the infrastructure that you want to configure with containers. For the Java side of things, we have integrations with test containers for Spring Boot and Quarkus. So the idea here is you add an extension, and then when you bootstrap your application, when you start your Java application locally, you will have like a Dapr running very close to your application using containers, and everything will be wired for you to just use the APIs. So you as a developer, you don't need to worry about like how Dapr is running, which message broker is configured. You just start your application, you can consume the APIs, and you can just develop your applications until you deploy that in a cluster where Dapr needs to be running and properly configured.
Okay, cool. Yeah, that's pretty cool.
But I think that for something that I would love to see is I would love to see like a tighter integration with Podman, where like an integration there with like a custom way of seeing kind of like what Dapr services are available, and that kind of stuff would be awesome.
Yeah, I mean in Podman there is the pod support, so even locally, and yeah, I mean that would be interesting. Yeah.
2025.
Yeah.
Some collaborations.
Another gift.
Cool. Yeah.
Abdel, do you have a question for Mauricio?
No, I just want to shamelessly plug our episode that we did with Mauricio on the podcast. So go look it up. It's episode 231. I should share a link somewhere.
That was really nice.
You can drop a comment in the chat. I think you can do that.
There you go.
No, yeah, I will share it. Let me make a QR code quickly and dirty QR code.
It was a really nice conversation, Abdel. I will always remember it because I remember how when I was explaining Dapr to you, you can like got the idea and then you start comparing with other tools. I really love that.
Yeah, it's clicked.
Yeah, okay, exactly.
We-
and I
we
can
had-
remember the exact moment when it clicked. So then you were excited about that.
Yeah.
It's good.
So here you have the QR code on the top for the episode 231 on the Kubernetes podcast. So check it out to get this discussion. Moving on to Abdel. So Abdel, thanks. It was a great introduction to, first of all, the introduction of what the value of service mesh is and what you resolve. So I think that is well covered in few minutes, because sometimes you can take more times to cover just this explanation. And then you covered pretty well the observability piece. One thing that I just wanted to add, because it's more like a reminder for people, is that to get the actual access log with details, or to get traces out of specific services, the actual service mesh, or Istio in that case, needs to know the protocol. And in Kubernetes, there is a parameter for services called app protocol, and many people using services in Kubernetes never configure that. Never. And you should do it, because at the end, by use app protocol equal HTTP or gRPC or Redis or whatever, it does technically help the service mesh say, oh, this is an HTTP communication, so I'm going to produce an access log with the HTTP format, or this is an HTTP application, I'm going to produce this man. So I think that's something that was missing, and I was just to remind it to the audience, because I think it's really important to remind it. And I had a question. You mentioned service mesh, ambient mesh, and you didn't touch base because there was so much. If we were starting this is going to be a never-ending presentation. And I think the sidecar model from Istio provides really rich observability. And I really like the fact that you were explaining that the type of observability that this was providing compared to another type of observability layers. But if people are interested to move on to ambient mesh, how much details would they get, and how much detail would they lose if they're moving to ambient mesh?
So from observability point of view, nothing changes. So very quickly, 10 seconds. What ambient mesh does is that it splits the functionalities of Istio into two layers. So instead of having a single sidecar that does all the stuff, you will have two proxies. There will be one proxy running on the node doing everything L4, so MTLS and some stuff. And then there will be something called the waypoint proxy, which is a namespace level proxy that does all the L7 stuff, right? So just splitting the functionality into two proxies instead of one, which you can enable and disable a hot plug basically when you need them. So metrics and distributed logs wouldn't change. The only thing that might change is the traces. So for traces, you need layer 7. So for that, you need the layer 7, what they call the waypoint proxy in the ambient mesh architecture. So that's not really a loss, in the sense that if you don't have the waypoint proxy, it probably means that your applications are actually not layer 7. They are only layer 4, and you don't need it. But if you need it, you need to enable the waypoint proxy, and you probably need to enable it for other reasons, and then you get the distributed traces out of the box, right?
But you don't get the as much spans as the proxy model, because the proxy model advantage is that it's going through the proxy anyway before hitting the service, so then it's great the spans. Would a waypoint proxy produce one
Everything
span?
goes through the waypoint proxy.
Yeah.
So
okay,
yes,
so we will have the same details.
Yes, even if the waypoint proxy is a single proxy for the namespace, so it's a shared proxy across all the pods in that namespace, it's able to impersonate every single pod individually. So you get the spans for every single pod.
Okay.
Yeah.
So just to summarize, so Z tunnel will be for TCP and
Layer
general
4,
communications, yes. And then if you need to define the traffic rules on the layer 7, this is where the waypoint proxy comes in the picture.
Correct, which is Envoy. So Z-tunnel is a Rust-based proxy that was built purposely for ambient mesh, and the waypoint proxy is still Envoy. So
another question, which is more on the observability side. So if I am a user that didn't have the investment in instrumenting my services with OpenTelemetry. And so I want to get started, and I want to have at least what we call the network, the communication to communication view. So at least I can see that, I'm slowing down on service B, for example. Would you recommend to start your observability or tracing journey by utilizing the what Istio or service meshes provides? So then once you get the details from the network perspective, and then if you see that service B is slow, then you can say, okay, now let's instrument service B. Yeah, so going through different lots, starting with the network and then moving on to the application.
I would say if you have it already, then use whatever it gives you out of the box. Installing Istio just to get those telemetry is probably an overkill because it will consume more resources than what OTel would consume, right?
Yeah.
It comes with a cost. The sidecars consume resources, the control plane consume resources. So I wouldn't install it just for the sake of getting the telemetry out. But if you already have it, the telemetry is already there.
But if I move to ambient mesh, then I'm at least...
Then it costs less.
Yeah.
And ambient mesh is GA, by the way. FYI, it's GA since like KubeCon North America.
And by the way, I have a questions from Mark. It says, what about ambient mesh? Will it take off? Is there an adoptions from ambient mesh, or is it still people still using an Istio because they trust in the Istio old sidecar model, or how is the adoptions on ambient mesh?
It's getting there again. It's GA since KubeCon North America, so a few months ago. So means it's stable and production ready. I don't have numbers out of the top of my head. I know that AWS offers actually like Istio with ambient mesh as a managed solution. So from my point of view, the moment a big cloud provider starts offering something as a managed solution, it's a good indication that it's mature, right?
Yeah, that's true. So that was my main question. So Mauricio, do you have any, and Mario, do you have any questions for Abdel?
I don't have any because I really like the idea of exploring ambient mesh. I would love to just give it a try and then see the differences. As an application developer, as Abdel mentioned in his presentation, right, I still need to care about like exposing my application level, metrics and everything.
Custom metrics, yeah.
Yeah, so I still need to do that. And also like something that I've suffered sometimes before is like about trace propagation, which is usually something that you will need to do in your applications themselves. Just like depending on how your services are interacting and sending requests between the applications, something that sometimes you feel that you will get out of the box when you use a service mesh, but usually you don't. And like with Dapr, you don't. You actually need to just do it in your application code.
So
same thing with Istio. So
yes.
Istio would generate the spans, but you still need to propagate them.
Yeah, and that this is important because if your application using, for example, B3 and you are using Istio is configured to W3C, then like there's disconnected. So you will have two traces for the same stuff. So this is where you need to be aligned with the service mesh configuration and your application configuration for sure. But I have tried service mesh a year and a half ago. Ambient mesh. So it was the early phases. It was I have an episode about it, but I will need to do a new one with the latest and greatest. But yeah, the observability piece was a bit for me. I was mainly I'm observability geek, so I was looking for the observability angle, and I was a bit disappointed. But now, if you say that, Abdel, those are more covered, then I definitely have to double look at another time and see the latest and greatest from the project. All right, so I think I'm looking at the time. Wow, I didn't pay attention. So 1:28. So I think we hit the record. We are the longest live stream from the Observable Lightning Talks. But it's a Christmas gift to you guys. I hope you enjoyed it. But yeah, thanks again, Abdel. Thanks, Mario. Thanks, Mauricio and Salaboy for presenting and interacting. I love the conversations. I could stay connected more and talk about those topics, but I think for the audience we need to wrap up. So I will disconnect your cameras and we can chat in a few seconds, guys. But I will just make a small conclusion and see you in a few seconds. All right. So thanks everyone for taking this hour and 29, almost an hour and 10 minutes for this live stream. If you didn't have the time to watch everything lively, then don't worry, the recording is available on YouTube, at least for a longer period of time. LinkedIn has it as well. But if you have any questions, like I mentioned to one of the speakers, because you're watching it offline, drop your questions and I will share it with the right speaker and I will provide you the answer. So if you enjoyed today's content, don't forget to like and subscribe to the channel. And again, thanks and enjoy the end of the year. Enjoy Christmas and see you in 2025. So it's time to close. See you. Bye.